It looks right skewed, I'm sorry. What do you guys think? Jordan?
I don't. What tool are we supposed to be using? Because all I see is the normal probability applet, and that's not what we're
No, no,
supposed to
no.
be
We're
using.
using the sampling distributions. It's the one with the four figures.
Where do you get the little thing to enter in all the numbers?
Oh, is so you go to today's, I mean the to this lesson, whatever lesson is 5 or 6,
Yeah.
and then you go all the way down to take action. Is I said that distribution of sample means the step one, step two, step three, four, and five, and then you'll get a link. It says go to the following link. This online stat book.
Okay.
So I'm reading in the
Homework. I mean the readings.
yeah, the reading. Okay, so it says for tremendously skewed distributions, a much larger sample will be required before the distribution of sample means is approximately normal. And so it must be at least 30. So since this is 5,
It is right skew then.
probably right skewed. Does that make sense? Am I
Yes.
thinking that right? I think.
Yes. So in order for so if there is like a right skewed, you know, histogram, but then if the sample is gray, then it will turn into normal, right?
I think so. Because in the reading it talks about having a sample size of 5. If the parent population is almost normal, then a sample size of n equals 5 will probably be sufficient to assure it will be. But that's if it's normal. So it's talking about if it's skewed. So if it's skewed, it will require a larger sample size, and which is around 30 is traditionally thought. Okay, so I think it's right skewed.
Okay. What do you think, Joel and Jordan?
It looks right skewed to me.
Yeah, I agree.
Okay, right skewed is next.
When you are taking a sample size of n equal 100, what is the shape of the distribution of means histogram when the parent population is skewed right?
That would be normal then.
Yeah, I think that's normal. So then I think 5 is what I just read. I think it'll be normal as well because it's already normally distributed. And
Yeah, it is normal.
that was kind of from the reading.
Yeah. If it's normal distributed, then it is normal then.
Yeah.
Yep. Question 6. When you are taking a sample size of 100 with what is the shape of the distribution of means histogram when the parent population is normally distributed? It's also normal. Am I
Yeah,
right or wrong?
I would say normal.
Okay. Oh wow, this is multiple choice. When would the distribution of means be normally distributed?
I think
So,
the first one, because it's normally,
but the sample is small.
right, but it's because it's normally distributed, you know?
Okay. All right.
The same for the large one.
Yeah,
So the second one is also true.
I think so. But not the third one. But yes, the third one does that seem right?
So it says so third says data are drawn from a population that is right skewed. and the sample size is small, so that is not correct.
Right, because it would need to be bigger for it to be
And
normally
then,
distributed.
and then the last one says the data are drawn from a population that is right skewed and the sample size is large.
Yeah,
Is that right or wrong?
I think that's
Right?
right. Yeah.
Okay.
Do you guys agree?
Yeah, because in the reading it says if the parent population is heavily skewed, then it will require a larger sample size to be sure that
Right.
X is normally distributed.
Okay.
Yeah.
Next. Which of the following give the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean will follow a normal distribution. For bell-shaped data, approximately 68% of the data will be within one standard deviation of the mean. About 95% of the data will be within two standard deviations of the mean, and approximately 99.7% of the data will be within three standard deviations of the mean.
I think it's the last one. I think the third one is the other one. Wait, this is yeah. I think the
So
third one is the law of large numbers, and the fourth one is the central limit theorem. I'm reading straight out of what I wrote down. I think that's
so if
as
the
sample size gets bigger, the distribution of the sample becomes approximately normal. So that's what that's saying.
okay, wait, I have my notes here. Central, right?
I wrote that one from one of the videos of the guys.
Okay, so the central limit theorem states that if the sample size is large, the sample mean will be normally distributed. Yep, you're right. You were right, Becca.
Okay.
Okay,
So we gotta do math.
that's what I think we need a formula for that one, right?
Well, this one I think we just need to write the mean.
Oh, the
Which
mean?
is that
Yeah, number 10.
mean?
The mean is 10.
Yeah. And
Standard deviation is 6.
Standard deviation 6.
well, wait, no, this is where we have to do the 6 over the square root of 36. It's that formula. Yeah, you take the standard deviation, which is 6, over the square root of the sample, which is 36. So that would equal 1, right?
Let me see.
6 over 36.
6 over the square root of 36.
Oh, yeah.
So it will be 1.
Yeah.
Yeah.
Okay.
And that for which one?
That's for 9. I mean, I'm
For,
sorry.
that's number 10.
I'm sorry. 10 is 1, and
10,
9 is
yeah, 9 is 10.
9 is 10. Okay.
So question 9 is 10. Question 10 is 1.
Right.
Yes.
How'd you guys get? I haven't even lifted my pen yet, and you guys have this figured out already.
I did a bunch of the homework. I tried. I don't know.
Well, the mean is 10, so the answer is there.
Yeah.
And then for the
videos go over this a lot, so it's in my brain. But yeah, I know it is confused. Like I would think The standard deviation is just because they tell you standard deviation is this, but you have to make sure to do that formula
Mm-hmm.
when you do the distribution of sample means.
Okay.
Okay.
So would 11 be normal?
Regardless of the distribution of the population, if the sample size is large, what would the shape be? I think they went over that in the video too. Let's see. It would be normal. Yes. Is that
So
what you, that's what you said, right? Yeah, normal.
that's the 11.
Yeah.
Okay.
And 12 would be law of large numbers.
Is that what that says? I don't know. Wait, why is it law of large numbers? Is that
It says the law of large numbers states that as the sample size increases, the standard deviation of the sample mean will get smaller. Let me see.
I don't know why then.
Okay.
I don't know what number 12 would be.
It's the central limit theorem because that's the answer that we used for number 8 is the best explanation of the central limits theorem.
Oh, yeah.
Identically distributed variables will be approximately normal regardless of the underlying distribution.
Yeah, I think it is a central thing too. That makes sense.
Okay.
Because it's big.
Okay. Should we submit?
I think so. I think we did good. To you guys?
Sure.
Sure.
Yeah. Submit. It's 100.
You did?
Yeah.
Nice.
Nice.
Woohoo.
Awesome.
Perfecto.
Alright, cool.
Okay, so what time
All
is the
right,
meeting on
guys.
Thursday?
We were gonna try for 5.
So
Well,
It will be 8 my
Oh.
time.
8, yeah, 8 for Carlos. Jordan, it would be 6 for you.
Okay.
is that okay?
Yeah, I work in the morning, so that should work.
Okay, cool.
All right.
Awesome. I think that's it, right? I'll stop this or I'll post this to the board.
All right, guys. Well, thank you for coming. Thank you for showing up.
Yeah.
That was quick and painless. Awesome.
Yes, all right. Hopefully everything will go smoothly for the rest of the semester.
Yeah.
Let me hear an amen.
Yeah.
All right. All right, guys. Good night.
See you Thursday.
See you
All right.
Thursday.
Thank you.
Bye.
Bye.